A new scientist here. It's really quite amazing. All of these scientists that we've been talking about are all connected one way or another, obviously with the brain and with language and stroke and those kinds of things, but they're also connected in life. I mean, it's amazing that a lot of these people living in the 1800s, 1900s, obviously had met each other, have reviewed their work together over the years. So it's really quite amazing because they did a lot of traveling and they didn't have airplanes back then. So it's really quite something. But the new scientist is called Santiago Ramón y Cajal, obviously from Spain. And he, among other things, he was what they call a histologist. Difficult for me to say. But basically, it's the study of microscopic structures of tissue. So they studied the brain, they studied the body by obviously getting material from dead people, and then would study that and beginning to understand how the cells work with all of that. So it's really quite amazing. And in his case in particular, because he did all his work, like we say, in a cave or in a dimly lit attic. Really quite amazing because that's what he did with a old microscope, which he just didn't have anything more than that. Yet he was still able to study it as much as he did for years and years and years, decades, trying to make this all work. And I say a cave because when he was young, his dad wanted him to become a doctor like his dad was and became. And the father would work during the day, and then in the evening, they didn't have any place to go for school. So they did use an abandoned cave, and he would take Cajal, Santiago, into that cave, and they would do all kinds of work, whether it be math, language, geometry, any number of things, as he began to understand better who he might be in the future. But as he got older, and his dad became the teacher for a anatomist teacher, studying the bones and the body. Eventually, of course, again, this is a long time ago, they didn't have any dead bodies and they needed them for class. So they had to go to cemeteries. And apparently they didn't have enough space. So a lot of times people be buried and then they needed more space and they would move them together into bigger and bigger groups of skeletons. So they would go there in the evening, during the night, the father and Santiago, to grab a whole bunch of bones and bodies to take back to his classes where they had to study that way, which is really quite amazing. But Cajal finished his schooling as much as he could and immediately signed up because back then it was mandatory to go into the military, and he signed up and eventually went to Cuba, where he immediately contracted Malaysia, unfortunately. So he didn't do a lot of action there, but he was an officer in the Spanish-American medical service, and he was there in Cuba for a long time, mostly sick most of the time, although he did go into a field hospital, but eventually made it home and then went and got his MD and started working on his patients, and then started working more on how the brain really does work. And what he was interested in was understanding how the cells work. And he did that for literally for decades in the attic where he lived, and studying all the time. And finally came across an Italian scientist named Golgi, who had figured out how to be able to what he ended up calling it the black reaction. With a bunch of chemicals, you can better able to see that some of these cells are transparent and others are black. So you could actually see what used to be just a mass. If you ever look now, you would see a mass of material. But to be able to see one cell versus another cell is very difficult. And Golgi figured out how to do that, but he didn't go far enough to be able to see not only the cell, which they could see, but the dendrites, what we now call the dendrites. They were just describing that and coming up with that word. But they still couldn't see it because it's just too fine, it's just too small. But they could see the cells, they could see the beginning of the dendrites, but then it sort of disappears into this mass, and they just couldn't figure it out. And one scientist, Golgi, thought that all of those cells, here's one cell, here's another cell, and here are the dendrites, and there are billions of them, that he thought that they were all fully connected, right? That they're completely connected. And Cajal, Santiago, had used Golgi's black reaction, and he refined it more so he could better see that the dendrites, he could actually see that they're connected, but they're not conjoined. So there's still a gap in between, and he could see that. And he wrote about that, studied it, and obviously had more tools than Golgi because he had changed the recipe for the chemical. So he was able to see it, and he knew that they ended free, what they call ending free, but yet they still transmit information from one cell to the other. And that's when we had Sherrington, the one we saw before, finding out he had these synapses at the end of all of these dendrites. They have these synapses, and then they would send information, no longer electrical, but now chemical. So they would come across this gap and go over to here and take off again. So anyway, all of that, how it came to be, and both Santiago and Golgi both get the Nobel Prize at the same time in 1906, because the people that were running that said, well, we don't know what to do, because obviously a lot of people learned a lot from Golgi, the black reaction, but Cajal has taken the next step forward, and now people can better see exactly what was happening. So there was this rival between the two, and the Nobel people said, well, we'll give it to both of them, and they'll have to continue to figure this out, which they did, of course, going forward. And it was Cajal that had figured out exactly how all that was going to work. And of course, by then, the part of this group of bands, as it were, of scientists, including Sherrington, had figured out the syntax, what makes that connection between one cell and another. Another scientist had come up with the word of dendrite. He's a German one, by the way. His name happens to be Wilhelm His. His. So you're starting to see the definition and the language of how they could build an understanding of how the brain works one step at a time, and then need the tool to be able to see what the dendrites would look like, what the syntax would look like, and how they could actually transmit information across a very small but still a gap, a synaptic gap. So all of that were coming together as they come to realize that. And once Cajal understood all that, started writing about it and speaking about it, with not only the Nobel Prize, but many other lecturers around the Europe countries. And that is when all of them decided that this is what it is. This is how the brain works. And this is what we now call the neuron doctrine, that allows us to better understand how dendrites and synapses work when it comes to the transmitting information between one cell to another, and networks, one network to another as well. So but once he got that done, all of his work had made its way into all of the textbooks and all of the scientific books within years, just years, so that even today, 100 and some years later, 150 years later, 125 years later, we, all of us, and I'm not a scientist, but I'd like to study it as if I were, but other scientists and myself and others looking at all the books we see, you can see the handiwork of Cajal, helping us understand what he understood then, wrote it down, beautiful pictures. Back then, they started obviously using pictures that could be useful. And plus, he was such a good artist that you can see how it was all working. And we get to see it today. It's exactly the same. We use the same tools that he used back then. But it's so interesting when he started seeing what they call the growing trees, right? Here's the dendrites, but when they're watching it, they can see it growing in a certain direction. What they call the arborization, the growing trees. And he referred to that as what he called well-directed mental gymnastics. Well-directed. So obviously there has to be what we now call experience-dependent neural activities. This is the mental gymnastics that allows people to grow dendrites and synapses and make the binding that we need to become learning through the neural networks. Because again, one cell by itself is very powerful, but it's still quite ignorant. It doesn't know what to do because it has to send something to something else and build a network that provides all of these disparate pieces of information and impulses to come together to start thinking more consciously about what otherwise those cells were not able, quote, to think until you bind them with others. So all of that he came to understand, and his description of mental gymnastics really is what we now call neurodependent, experience-dependent neuroplasticity. And he figured all that out. Of course, he lived a very, very, very long time and was quite older, as many of these scientists were. So he was able to go through all of that, going through decades of studying with older tools that wouldn't work, invented new tools, started using those for another 20, 30 years, using those new tools to better understand what all of them had looked at 50 years ago, and they either couldn't see it, couldn't understand it, didn't have the language that could help them go forward. But doing that for 80 years, as it were, then he was able to invent what needed to be invented and go forward with the new language they had and the new skills. So that is Santiago Ramón y Cajal from Spain. He is quite a guy. And really now we understand a lot more about plasticity, the neuron doctrine, and how plasticity really is the foundation for all learning. So we'll get to talk about this with many more scientists coming forward in the next couple of months. But Cajal is quite a star for me. Nice to see everybody, and I will see you in a couple of weeks. Take care. Have a good day. Bye-bye.